A windy marathon and a sunny marathon. The table below gives some details on the finishing times for the two marathons. For each marathon, the finishing time of the runners were approximately normally distributed. Circus Precision Marathon was based on her finishing time. She came that place in the windy marathon, which means so exactly 5,264 out of 6,000 runners had a finishing time that was less or faster. Okay? Using this fact and details in the table below, estimate circus position on the sunny marathon. Show all of your workings out. Okay. Now, that's interesting, all right? So, what we're going to do is we're going to get to her position, which is this position here, right? Is that all right? Out of how many? 6,000. And I'm finding out what percentage of the population got a faster time than her. Is that all right? 8,775. Is that all right? So I was to draw this on a curve, okay? Now, can we all agree that faster times are smaller? That makes sense. The yellow region is the faster times, and the blue region is the slower times. Would that make sense to everybody here? But what percentage? She's one of the slower times, isn't she? So she'd be up here somewhere. Would you agree with that? And how much of the population would be behind her? What population would be behind her, guys? 0.8, was it? 8,775, right? That's how many people are behind her. I'm going to find a Z score for this, okay? So how do I find a Z score for this? We go to our table. We're looking for a Z score of, we're looking for a Z score that creates a percentage of 0.8775. Now, we're looking through here on our Z scores, 0.8775. Now, there's two of them. There's 1.16, which is closer, and 1.17, which is larger. So I'm happy to go with 1.16. Is that okay? The closer one? Okay, so I'm going to go for the closer one. A Z score of 1.16. Okay, and that's taken from the tables. Would you be happy with that? Okay. Now, what I want is her position in the marathon. Isn't that right? Okay. So, okay. Now, does it give us the mean time and all? All right. So, what we're going to find is her time. No matter what marathon she's in, we assume she can run the same time. Would that be fair to say? Oh yeah, it does. Where does it say that? Yeah. So guys, that's where I was sort of lacking my information. I knew I was missing something. We're going to find her finishing time in the first marathon, and then we're going to use that finishing time for the second marathon as well. So here's what we're going to do. She's above the average, isn't she? So a Z score means she's 1.16 standard deviations above the average. So the average of the first marathon was 254. And then you add 1.16 times the standard deviation, which is 38. This means she hit a score of 298 minutes and 0.8. Is that okay? That's her time. Because she's 1.16 standard deviations above the mean. Is that cool, you guys? Now, what we're going to do next is we're going to find out her Z score. Is that all right? Now, I wonder if we're going to, last day we got tricked by trying to figure out do we need to go below or above, okay? So let's find her new Z score. So what's her Z score going to be? It's going to be X, take away the mean all over the standard deviation. We're still assuming she can run this score for the second race. And we're going to take away the standard deviation, which is what? Oh, sorry, the average, which is 247. Okay, then what we're going to do? Anybody else? Over 29. Did anybody get a Z score of 1.76? Okay, 137, so to speak, but we're not going to take all that into consideration. All right, so 1.76 will do me. All right, guys. Now, we're going to have to figure out where she placed. Now, a set score of 1.76, what does that mean? Below the mean or above the mean? 1.76 above the mean. And remember what I said, this side is the slower times, and this side is the faster times. Let's find out what percentage of the population have a faster score than her. So we go to our tables and we look up 1.76. So where is 1.76? Okay. Who got this one here? Who got 0.9608? So basically what we're saying is that 96% of the population got a faster score than her. Yeah? How many participants in this race? 2,000 participants. So 2,000 participants multiplied by 0.9608. And what do we get then? You got 1921.6, okay? So they actually gave both results. You could say that she came 121st or 22nd. This gave both answers. Sorry. I don't know what's a tit, but it is apparently. So either one of those two will do you the answer. I think I'd have inclined to round up. I probably would have favoured the second answer over the first, but both answers were acceptable.